Hi everyone, my name is Suram and I welcome you all to my YouTube channel. Today's video we are going to discuss about the same chapter that we have discussed in the previous video. Chapter number 7, Energy Flow and Practices for the Conservation of Resources. That is of standard 9th. First part we have done in previous video, and today's we are going to discuss about the second part. Actually this chapter is quite long, so I have divided this chapter into 3 parts. So today we are going to discuss about the second part. So that is the solar cells. Solar cells, what are these cells? A solar cell is a device which directly converts the solar energy into the electrical energy, and this is also known as the photovoltaic cell. This is also known as photovoltaic cell. And the solar cell is, in this, the photo stands for the light and the voltaic stands for the generation of the potential difference. Photovoltaic cell means photo stands for light and the voltaic stands for the potential difference. And photovoltaic cell is a device which converts light energy into the electrical energy. So that it is converting into electrical energy due to the generation of potential difference, because voltaic is the potential difference. So what is photovoltaic effect? Photovoltaic effect, the phenomena due to which the light energy directly changes to electric energy when light is incident on certain sensitive material, that is known as the photovoltaic effect. So it must be kept in mind that during the photovoltaic effect, it is the light energy only which that is changing into the electric energy. So radiant heat present in the solar energy does not change into electric energy. So it is the heat energy, light energy, which is changing into the electric energy. So during this conversion, the radiant heat present in the solar energy, heat that is present in this solar energy, does not change into the electric energy. It is the light energy which is changing into electric energy. That must you keep in mind. So next we have the semiconductors. Semiconductors, what are these? These are the substances which neither are good conductors of or not the good insulators of the electricity. For example, the germanium and the silicon. These are some substances which are not either the good conductors or neither the good insulators of electricity. So it has been noticed that when the light energy falls on the semiconductors, the electrical conductivity increases. This electrical conductivity can be increased when the light energy falls on it. So what are the uses of these semiconductors in solar cells? So in solar cells, electrical conductivity of the semiconductors such as silicon or germanium can be changed by treating them chemically. If we treat them chemically, then the electrical conductivity can be changed. For example, when the boron or sulfur is added to silicon, its electrical conductivity enhances manifold. That is increased. So the process of adding impurities to the semiconductors, that is known as the doping. So the semiconducting material doped with boron has the affinity to attract the electrons. So it is commonly called the p-type acceptor semiconductor or the p-type semiconductors. That means these are the acceptors. And conversely, the semiconducting material doped with the phosphorus has the surplus of electrons. So it is commonly termed as the n-type, or means the donor semiconductors. So semiconductors depends on the types of impurities added. Either it can be p-type or n-type. About these in detail you will study in the higher classes. Then how we can make a solar cell. Is it the making of the solar cell? In the solar cell is essentially a very thin sandwich of N or P type wafer, thin semiconductors of silicon. Either it can be P type or N type, is it? So in which a U-shaped metal grid is placed. The lower end of the sandwich is fixed to the metal base, is it? Lower end is fixed to the metal base, and the grid has another lead which can be connected to the another solar cell in series, is it? So different cells are connected in the series. The upper surface of the semiconducting sandwich is coated with anti-reflection coating. There's anti-reflection coating on this, is there on this, is it? So when the visible light falls on this solar cell, the N-type wafer produces a large number of electrons, is it? So these electrons drift towards the P-type, is it? N-type is electrons are drifting towards the P-type wafer, therefore generating an electric potential. So due to this, some electric potential is created. So the potential difference produced by the single solar cell is 4 centimeters square and is between the 0.4 to 0.5 volts, is it? So the magnitude of the electric current is 60 milliamperes, or that is 0.06 ampere. However, when the large number of solar energy are connected, when the large number of solar cells are connected in the mixed circuit, the some cells are in series and some in parallel, a large potential difference of a large current can be obtained, is it? So mean we can produce a large current. So the group of solar cells connected in specific pattern to produce the desired potential difference and magnitude of the current is called the solar panel. So just collectively known as the solar panel, is it? So solar panel is placed on the tall spotting pole that you might have seen in the solar light, is it? And there is one solar panel also when we are producing the solar energy. When we are using the solar energy to convert into electric energy, such that it faces directly towards the sunshine, is it? So solar energy falling on the solar cells is converted into the electric energy which flows the storage battery through the connecting wires. It has the battery also connected, and the storage cell of the electricity is stored in the form of chemical energy. So when it is required to pump a water, storage battery is connected to the electric motor, and which can be further connected to the shaft of the pump, is it? So the chemical energy in the storage battery changes to electric energy and hence it drives the pump, is it? So it can be used to lift the pump water up to the certain height, is it? So what are the uses of solar cells? Solar cells, these are used for the wide variety of applications. It is used in toys, watches, calculators, then electric fences, is it? The remote lighting system. It has a wide applications, uses then water pumping, is it? Water treatment, emergency power, and the portable power supplies and the satellites, is it? So these are some applications or the uses of solar cells. Then next we have the wind energy. Wind energy. So air in motion, that is known as the wind, the moving air, is it? The air in motion is known as the wind, is it? And the moving air has the kinetic energy, is it? So the energy of the wind depends on its velocity actually, is it? Air moves, it possesses the kinetic energy, is it? So energy of the wind depends on its velocity. So if the air is stationary, it has no kinetic energy, is it? So when it starts moving, the energy increases in proportion to its velocity, is it? So it means more is the velocity, more will be the kinetic energy. So the fast moving air causes a dust storm, is it? So as it carries the dust also, and a wind blowing with the hard wind blowing very hard has the devastating effects also, because it can cause a storm in the sea, is it? As well as it can uproot the trees on the ground, is it? So wind blowing very hard can has the very devastating effect. You can say this, the storm, when the storm comes, these trees can be uprooted from the ground, is it? And it can cause various other effects also, is it? So next we have the windmill for the generation of electricity, is it? Or that is known as the electrical wind machine. So in the recent years there has been a great interest in producing the electrical energy from the wind energy by using the windmills. So especially in the rural areas, is it? In the rural areas that it is used especially. So windmills that generate the electricity are conventional in their propeller designs, is it? So which implies the 2 or 3 tapered blades. There are the 2 or 3 tapered blades are there here, is it? So these are the traditional design of the windmill, is it? So shaft of this windmill is connected to the shaft of the armature of the generator, is it? At the back there is one shaft which is connected to the shaft of the generator. So when the fast moving wind rotate the blade of this windmill, is it? So when this windmill is rotated, the armature inside the generator rotating armature produce the electric current, is it? So thus the kinetic energy of the wind converts into the electric energy, is it? So the amount of electric energy produced depends on the velocity of the wind, is it? So the electrical wind machine have been designed which have the capacity of 1 megawatt to 5 megawatt, is it? So the electric energy produced by harnessing the energy of wind is not very dependable, as the wind does not blow all the time, is it? So thus some backup sources of electric energy is always needed when the wind is not blowing, is it? So it can be placed in that areas where the wind is flowing continuously, is it? So this is one of the major drawback of this, you can say. So where the wind energy in India, is it? Where is the wind energy in India? Where are the wind power plant, you can say? It is in islands of Arabian Sea and the Bay of Bengal, then coastal belt of the Gujarat and southern Tamil Nadu, and parts of Rajasthan, western Madhya Pradesh and Karnataka, is it? So these are the places in India. Then next we have advantages and disadvantages of the wind energy, is it? So advantages: wind energy is natural resource and is available without any cost. We do not have to pay any cost, is it? Because it is free of cost. And wind energy doesn't cause any kind of pollution also, is it? What are the disadvantages? Wind energy is undependable, as fast moving wind is not available all the time at a given place, is it? This is one of the major drawback, you can say. Then we have the windmills and the wind turbines remains unoperational when the wind is not blowing, is it? So this adds up to the operational cost also. When it is not used for the long time, then it can cause the various effects also to the windmills. So these are some advantages and disadvantages of wind energy, is it? And wind with the uniform velocity cannot be expected, is it? All the time it is not expected that the velocity will be uniform for the wind, is it? So these are some advantages and disadvantages of the wind energy. Then we have the Hydel energy or the hydroelectric energy, is it? Hydel energy or hydroelectric energy. So hydroelectric power plant is an arrangement in which the kinetic energy of the flowing water is transformed into the electric energy, is it? And the electric energy generator is called the hydroelectric energy. So this is the hydroelectric power plant, is it? So dam is made, is it? So the energy converted of this water into the electric energy, that is known as the hydroelectric energy, is it? So the moving water is used to produce the electric energy. So this electric energy so produced is known as the hydroelectric energy. So then we have hydroelectric power station or the hydro power station. How it work actually: in a hydroelectric dam, water is stored in the reservoir, is it? In the reservoir there is the water here, and as the height of the water in the reservoir rises, the potential energy stored in the water increases, is it? So potential energy of the water increases, and in order to convert the potential energy of the water into the electric energy, is it, the iron gate near the bottom of the reservoir is raised, is it? The iron gate here is it is raised with the help of the control gate, is it? So as the water rushes out from here, is it, and potential energy of this water changes into kinetic energy, is it? And this energy in turn rotates the blade here, is it? It rotates the blades of the turbine, and the turbine is coupled to the generator, is it? This turbine is attached with the generator, is it? And when the coil of the armature of the generator turns rapidly, is it, in the magnetic field, so this will produce the electric current inside the wires or inside the coils. The electric energy so produced is fed into the step-up transformer, is it? It is supplied to the step-up transformer, and it is used, and it is taken to the distance places, right, through the high tension wire, is it? So from here it can be taken to the different places, is it, by using the high tension wire. You might have seen these electric poles, is it? So this is how the hydroelectric power station or hydroelectric power plant work. Then what are the energy changes taking place in the hydroelectric power station? In the hydroelectric power station, first of all, the potential energy of the water changes into kinetic energy. Here the water is having the potential energy, so this will change into kinetic energy first, is it? And the kinetic energy is changing into the rotational energy of the turbine. Here the kinetic energy is changing into the rotational kinetic energy of the turbine, and the rotational kinetic energy of the turbine changes to rotational kinetic energy of the armature. This is moving the armature here, is it? Armature of the generator. It is producing the rotational kinetic energy. Then the rotational kinetic energy of the armature changes into the electric energy of the coil, is it? Here the electric energy is produced, right? So these are the energy changes taking place in the hydroelectric power station. Then what are the advantages and disadvantages of the hydel energy? So first of all, advantages: the water required for the generating hydel power is available free of cost, is it? Means we do not have to pay anything for this. And the hydel power stations are pollution free, it's not causing any kind of pollution. Then what are the disadvantages? For running a hydel power station throughout the year, a vast amount of water is required, is it? So this demand a vast reservoir. So the minimum height required to convert the stored potential energy of water into electric energy is 34 meter, is it? So this involves a massive investment in the construction of dams. So we have to make the big dams, is it? So minimum height is required is 34 meter, is it? So it requires a very high cost, a massive cost is required, we can say, to build the dam. So these are some advantages and disadvantages of the hydel energy. Then we have the energy from the sea. Energy from sea, that is in the form of tidal energy, is it? So during the tides, an enormous amount of water in the sea rises up, is it? And the tides have the enormous amount of mechanical energy actually, is it? Some of potential and kinetic energy. So this energy can be used to generate the electricity, is it? So the tides have the enormous amount of mechanical energy, so this can be used to generate the electricity. So tidal power plant is constructed near the narrow bays, is it? So when the water level rises up and then it falls, so tides, then it falls down appreciably during the tides. So this shows the dam as constructed, is it? Here the dam is constructed, and tides, the water is allowed to pass through the dam walls by opening the gate, is it? Here is a gate. So tide flow from this way. So when the level of the water tends to fall during the low tide, is it? So then the gates are closed, is it? And the gates are closed and the seawater collects behind the dam on the or at the higher level and such has the potential energy. So this stored water is allowed to fall on the blades of the turbine, is it? So this stored water is allowed to fall on the blades of this turbine, and which is connected to the generator here, is it? This is connected to the electric generator. So kinetic energy of the outgoing water, so kinetic energy of this outgoing water is changing into electric energy, is it? So such tidal power plant have been constructed in Canada and France, is it? So this has been constructed in Canada and France to convert this tidal energy into electric energy, is it? So although the tidal energy is being generated in India also, is it? So there are 3 kinds of sites have been identified, is it? That is Gulf of Kutch in Gujarat, then Gulf of Cambay in Gujarat state, then Sundarbans along with the east coast of West Bengal state. So these are some sites where the tidal energy is used, is it? Then we have the wave energy. So in certain coastal region the wind blows very fast over the surface of sea, is it? So this gives rise to the waves which has a large amount of kinetic energy. So specially designed floating devices can set up in such a region, is it? So a small water turbines is these devices can change the kinetic energy of the sea waves into the rotational kinetic energy of the turbines, is it? So this energy can be converted into the electric energy through a series of dynamos. So this waves energy can also be used for the production of electricity, is it? So basically it is used into 2 types of ways. So very first is the floating type, is it? So one idea is to set up the floating platforms. The floating platforms are there, is it? So that are coupled with the generators, and the floating platform will move up and down. This will move up and down and along with the waves, so thereby converting the kinetic energy of the waves into a rotational energy and then electric energy, is it? So because of the movement, here is the dynamos, series of dynamos are placed inside it, right? So because of that, because of the waves, it is converted into electric energy. Then another idea is set up the sea waves moves up and down inside large closed tubes. Inside the large closed tubes it is moves up and down, and as the water will move up and down, it will compress the air within the tubes, is it? So air within the tube is compressed, and the compressed air can be used in driving the turbines of the generator, is it? So this compressed air can be used to rotate the turbines, is it? And hence it produces the electricity. So this is how the wave energy can be used to produce the electricity in 2 ways, is it? The next we have the geothermal energy. Geothermal energy in the earth from within is very hot, is it? As you know, in the earth within it is very hot, is it? Because magma is one of the heat source inside the earth, is it? And the heat inside the earth under favorable conditions can be utilized in some of the source of energy, is it? So this energy is called the geothermal energy, is it? So this energy, this geothermal energy, geo means the earth and the thermal means the heat. So it means that geothermal energy can be defined as the heat energy from the hot rocks present inside the earth. So it is among one such sources which do not come directly or indirectly from the solar energy, is it? So it is not coming directly or indirectly from the solar energy, is it? It is directly coming from inside the earth, is it? It is not because of the solar energy. Then we have the origin of geothermal energy. What is the origin of geothermal energy? So we know that the deeper regions of the earth crust are very hot. In these regions there are the rocks melt in the form of magma that we have seen in the previous slide. So geological changes in some region of the earth push magma upward, is it? So this very hot magma collects in some of the depths below of the surface of earth. So the places under the surface of earth where the hot magma collects at fairly a less depth are called the hot spot of the earth, is it? So hot spots are source of the geothermal energy, is it? So what is the reason of the geothermal energy? It is the hot spots present inside the earth, is it, in the rocks, that are the main source of geothermal energy. So how it can be harnessed? Harnessing the geothermal energy. Harnessing of geothermal energy. So in some of the geological region of the earth, the underground water comes in contact with the hot spots and it changes into steam. So this steam gets trapped between the underground rocks and get compressed at very high pressure. So this steam is extracted from the ground by sinking the pipes from the surface, is it, of the earth. The steam coming up at high pressure is used to running up the turbines connected to the generator here again in the same way, is it? So this steam can be used to rotate this turbine. So this turbine is attached with the generator. So on moving this turbine, the electricity will be produced, is it? So this is how this geothermal energy can be used for the production of electricity. Second is, in some of the places the steam formed under the surface of earth does not get trapped. Instead it forces its way up, is it? It does not get trapped, or it is coming out, is it, from the surface of earth. And hot water comes out and it gushes out from the surface of earth to form the natural geysers, is it? So it will form the natural geysers here, is it? So the heat energy brought up by the natural geyser is used to generate the electricity, in as we have discussed already in the previous slide, is it? Then in some of the geological regions of the earth there may be the hot spots, is it? So but the underground water does not come in contact with them. So in such of the region there are the two holes made in the earth crust that we have seen in the first slide already. Throughout the one hole is pumped in cold water, and the cold water in contact with the hot water changes into the steam. So this steam can be used again for rotating the turbines and for the production of electricity. So what are the advantages of geothermal energy? Advantages are, it can be harnessed 24 hours a day, is it, throughout the year, you can say, and it is non-polluting and environment friendly, and it can be produced at half of the price as compared to the conventional sources of energy, is it? So there are some disadvantages of geothermal energy also. What are the disadvantages? Geothermal energy is available only at a few places which are geologically suitable. It is available at the very few places. So geothermal energy requires a deep drilling which is highly technical and expensive, is it? So where are the locations of the geothermal sources? Geothermal sources locations are, in India only one place is there, is it? India only place is there where the geothermal energy can be harnessed. It is in Madhya Pradesh, is it? So in the world the geothermal energy is successfully harnessed in New Zealand as well as in the United States of America, is it? So this was all about the second part. So in the next video we will discuss about the third and last part of this chapter. Thank you.